All right, these are the 6.1 and 6.2 notes. We are talking about exponential functions and their graphs. This is page 1. So first things first, we want to make sure that you remember some of the properties of exponents. The first one, 2 to the a plus 3, is kind of backwards from how we usually see it. But if I have 2 to the a plus 3, I know that I add the exponents anytime I multiply two numbers with the same base. So this is going to be the same as 2 to the a times 2 to the third. 2 to the third is 8, and I can rewrite that as 8 times 2 to the a. I do want to keep that 8 separate from the 2, because the 2 will change as a changes, or sorry, the 2 to the a value will change as a changes, the 8 will not. When we have a power, remember that when we have a power under a radical, remember that the index on that radical can be written as a fraction. That index is actually the denominator of that unit fraction. I get x to the 2 over 10 here, which reduces to x to the 1/5. C, we're going to use the power to a power property. Remember, this 3 outside has to apply to both the 2 and the square. I get 5 times negative 2 to the third times x squared to the third. Negative 2 to the third is negative 8. When we raise a power to a power, we multiply them. I get negative 40 x to the 6th. So just to write these out, if I am multiplying two numbers that have the same base, we add the exponents. Multiply those exponents. If we are taking the power of a product, that product has to apply, that exponent has to apply to both parts of the product. And we can combine the two above. When we have quotients of powers, we're dividing two numbers that have the same base. We subtract those exponents. Here is one of the most important ones. Anything to the 0 power is always 1. A negative exponent does not change the sign of the number, does move the value into the denominator. And anytime we have something written as a rational exponent, we can rewrite it as the radical. Okay. Example 2 here, our exponential functions. We are going to write in the form a plus b to the x. A cannot be 0, otherwise this is just 0 everywhere, and that's boring. B has to be a positive number. The base has to be a positive number. Okay. A is our initial value. That's what happens when x equals 0. Because if I have a times b to the 0, b to the 0 is 1. That's just a. Sometimes you'll see it called a sub 0 or a naught. It's the value of a when your input is 0. And then 2 quick graphs down here. It's exponential growth. If the function is going up to the right, it's exponential decay if the function is going down. Okay, so it's going to be exponential growth if our base is greater than 1. And it's going to be exponential decay if our base is between 0 and 1. Remember, it's got to be positive. And that's page 1.